Welcome guys to our second flipped classroom this year. For tonight we're going to do lessons 2.2 and 2.3. Since both lessons involve solving simple inequalities, one-step inequalities, we're just going to do both lessons together. Our essential question for these two lessons is how can you use addition, subtraction, multiplication, or division to solve an inequality? If you remember our lesson yesterday, we learned about our inequality symbols. We have greater than or less than. We have greater than or equal to or less than or equal to. So these problems are going to look a lot like our simple equations that we solved, except instead of equal signs, we're going to have these inequality symbols. The inverse operations that we use are not changing. Addition will still undo subtraction and vice versa, and multiplication will still undo division and vice versa. So really solving these inequalities should not be too difficult. In example number 1, it says solve the inequality and graph its solution. So if you're looking at letter A, you can easily see that we need to isolate the variable b. In order to do that, we need to move the 2 to the other side of the problem. So since that is a minus 2, we are going to add 2 to both sides of the inequality. Because remember, what we do to one side, we must do to the other. This works with inequalities as well as equations. So this cancels out and b is greater than 11. Now, we learned yesterday to graph an inequality, we graph it on a number line. And I want your number in the middle, and then I want you to do one number to the right of it and one number to the left. Based on the fact that this is a just greater than symbol, we know our circle is going to be open on the 11. And since all of our answers are supposed to be greater than 11, we know that our arrow will be pointing to the right because all the values to the right of 11 are greater than 11. Now, if you move to letter B, you can see that m needs to be isolated. In order to do that, we need to move 3 to the other side. And since this is minus 3, again, we're going to add 3, and we're going to do it to both sides of the inequality symbol. So m is greater than or equal to 5 plus 3, which is 8. Again, when we graph this, we're going to draw a number line. The number from our problem is an 8, so we're going to put it in the middle, and we're going to do a 9 to the right and a 7 to the left. This one is less than or equal to. So that means 8 is included in our solutions. So we're going to color that dot in to show that 8 is one of our solutions. But all of our other solutions are supposed to be less than 8. So this time our arrow is going to go to the left because values get smaller as they go to the left. Let's move on to letter C. We have negative 2 and 3/10 is less than p plus 7/10. Now nothing's going to change. Just because our variable is on the right side of the problem, nothing's going to change right now. We still want to isolate the p. So in order to do that, we're going to subtract the 0.7 from both sides of the inequality. Since our signs are the same, we're going to add and keep. So this becomes a negative 3 is less than p. Now, I taught you yesterday, we always want our variable on the left side. So you've got to be very careful when you rewrite this problem. If we're reading an inequality, we're going to read starting with the variable. So if I read this problem starting with p, it reads p is greater than negative 3. So when I rewrite it, I want to make sure it still reads p is greater than negative 3. And let's go back and let's box in these answers because we do want our answers to stand out. So let's go back and box those answers in. Now, we're going to graph it. So again, our negative 3 is going to go in the center of our number line. We want a negative 2 to the right and a negative 4 to the left. Remember, negative numbers can be tricky, but negative 2 is bigger than negative 3. So a negative 2 to the right and a negative 4 to the left. We know that our symbol is just greater than, so our circle is open because negative 3 is not one of our solutions. If all of our solutions are greater than negative 3, then our arrow needs to go to the right because all of the numbers to the right of negative 3 are larger. Letter D. Same thing. It's okay that z is on the right side of our problem. We'll deal with that at the end. For now, let's get z by itself. And in order to do that, we have to subtract 1/6. All right? I noticed on our test this week, some of us thought because it was a fraction, we had to multiply it on both sides. No, they are adding 1/6, so we are going to subtract it. It cancels over here. And 5/6 minus 1/6 is just 4/6. Now we will take care in just a second and we will reduce that because we always want to reduce our fractions. So again, we start reading this with the variable. So if I start with the variable, this reads z is greater than or equal to 4/6. So when I rewrite this, it still needs to read z is greater than or equal to, and I'm going to take this opportunity to reduce 4/6, and that is going to give me 2/3. So for this one, z is greater than or equal to 2/3. Now, let's go over here to the side because we're kind of out of room on our screen. Let's go to the side and let's graph this one. In the center, we're going to do 2/3. Now the easiest thing to do, add 1/3. Add 1/3. 2/3 plus 1/3 would be 3/3 or 1. And then let's subtract 1/3 going the other direction, so it would be 1/3. Our circle, it's greater than or equal to, so our circle is closed because 2/3 is a possible answer. And all of our values are supposed to be greater than 2/3. So we're going to draw our arrow to the right. Now, if you notice in example 1, these all used addition and subtraction. So we solved these simple inequalities using addition and subtraction. Now let's do the same thing in example 2, except this time we have to figure out what the inequality is going to look like based on these sentences. So we're going to write the sentence as an inequality, and then we're going to solve it. Notice it does not ask us to graph it this time. We're just going to write the sentence as an inequality, and then we're going to solve the inequality. So let's look at this. It says a number plus 8. Now we've learned in the past, anytime we see a number, we replace that with a variable. And I'm just going to use x. You can use whatever variable you want, but I'm going to use x. Plus 8, so that's pretty straightforward. X plus 8 is greater than. So we know since the words is greater than are there, that it's going to be a greater than symbol. And a number plus 8 is greater than 11. We want to get x by itself, so we are going to move the 8 by subtracting it from both sides. So x is greater than 11 minus 8 is 3. And again, doesn't ask us to graph, so we're done. I want you to take a minute and I want you to see if you can figure out letter B. Hopefully you paused the recording and wrote down the answer to letter B. But 6 is less than or equal to. So we know we've got 6. It says is less than or equal to. So this becomes a less than or equal to symbol. And it's the sum of. Now the sum of is an addition problem. We know that the sum is the answer to an addition problem. So let's go ahead and put that plus sign down. What are we adding together? What are we trying to find the sum of? A number and 15. Since the words a number come first, we're going to put the variable first, and I'm going to use n this time. You can use whatever you want, but it's the sum of n and 15, so n plus 15. Now, if we want n by itself, we move the 15 by subtracting it from both sides, and we have negative 9 is less than or equal to n. But we know that when we write our final answer, we want the variable first. So if we read this starting with the variable, it's n is greater than or equal to negative 9. So make sure when you write down the final answer that it still reads n is greater than or equal to negative 9. And that's the answer that you want to box in. Now, example number 3. Again, we're solving the inequality and we're graphing the solution, but this is where we have to be careful. Since these problems include multiplication and division, we have to be very careful. We talked about this yesterday, but when the last thing you do is multiply or divide by a negative number, you must flip the sign. So let's look at letter A, and let's see if this requires us to flip the sign. If n is the number that I'm trying to isolate, I know that this problem reads n divided by 7 is greater than or equal to -1. So when I move the 7, since they are dividing it, I'm going to multiply it on both sides. So my 7's cancel because they equal 1, and n is greater than or equal to -1 times 7 is -7. Now the question I have to ask myself, is the last thing I did multiply or divide by a negative number? Not is my answer negative. Is the last thing that I did multiply or divide both sides by a negative number? And I clearly multiplied both sides by a positive 7. So I do not need to flip the sign. I do, however, need to graph this. So once again, we're going to draw our number line, put our -7 in the middle. We'll do one number to the right, which is -6, and one number to the left, which is -8. When we look at our symbol, it's greater than or equal to, so we know it's a closed circle because -7 is one of our solutions. The rest of our solutions are supposed to be greater than -7, so our arrow is going to go to the right. Now let's look at letter B. We have 1 is greater than or equal to -1/10 z. So here we are, we're trying to isolate z, and we're trying to move a fraction. Now this is a multiplication problem. So when I'm doing a multiplication problem and the number that I need to move is a fraction, I'm going to take a shortcut. I'm going to multiply both sides by the reciprocal. And the reciprocal of -1/10, if I flip that, is just going to be -10. So I am going to divide both sides by -10. A reciprocal times itself equals 1. And we're left with z is less than or equal to -10. Now again, we want our final answer written with the variable first. So if we read from the variable, that reads z is less than or equal to -10. So we've got to make sure our final answer still reads z is less than or equal to -10. Now the question, before we box this in, is the last thing we did multiply or divide by a negative number? And hopefully you can see that the last thing I did was I multiplied both sides by a -10, which means my final answer is actually going to be z is greater than or equal to -10. I must flip the sign. So this is one of those problems where we have to flip the sign. Let me go over again why we did that. In order to get z by itself, I had to multiply both sides by a -10. Since that was the last thing I did to solve the problem, that means I have to flip the sign in my final answer. So right here, it was z is less than or equal to -10. So I rewrote that. Okay, all I did here is rewrite what was already there. Then I asked myself the question, do I need to flip the sign? And I did. So I flipped it, and my final answer became z is greater than or equal to -10. Now let's graph this. In the middle of our number line, we're going to put a -10, to the right a -9, and to the left a -11. Our symbol is greater than or equal to, so our circle is closed, and all of our values are supposed to be greater than or equal to -10, so our arrow is going to go to the right. All right, let's look at letter C. If we read this, it reads -4 2/10 times m is greater than 6 3/10. So we know this is a multiplication problem and we're trying to get m by itself. The inverse of multiplication is division, so we're going to divide both sides by -4.2. We know that anything over itself equals 1, and we know that once we work this out, our answer is -1/5. Now, this is one of those instances where I am okay with a decimal answer because the problem started with a decimal. All right, this problem started with decimals in the original problem, so I want a decimal answer. But before we box this in, let's ask ourselves, do we need to flip the sign? The last thing I did to get m by itself, I divided both sides by a -4.2. So once again, we do have to make sure that we flip the sign and we get m is less than -1.5. always ask yourself the question, do I need to flip the sign? So when we graph this, we're going to have negative 1.5 in the middle. We can go to negative 1 to the right, and we can go to negative 2 to the left. Our symbol is just less than, so this time our circle is going to be open, and since all our solutions are supposed to be less than negative 1.5, our arrow is going to go to the left. I want you to pause the video and take a minute and work letter D. Hopefully you paused the video and you worked letter D, but now let's work it together. If I want R by itself, and I know that that reads negative 2 times R, I know that I've got to divide both sides by negative 2. R is less than. A negative 22 divided by a negative 2 is a positive 11. But remember, the last thing we ask ourselves, do I need to flip the sign? Since the last thing I did to get R by itself was divide both sides by a negative, the answer again is yes, I need to flip the sign. So my final answer is going to become R is greater than 11. When I graph this, 11 goes in the center, 12 to the right, and 10 to the left. My symbol is just greater than, so my circle is open. Since all of my solutions are supposed to be bigger than 11, my arrow will go to the right. So hopefully you took the time, you paused the video, you worked that out, and you got the correct answer. Now to finish this, we're going to look at example 4. We're going to write and solve the inequality. Again, not looking for you to graph it, just looking for you to write and solve the inequality. It says you have $12 to buy 5 goldfish for your new fish tank. Write and solve an inequality that represents the price you pay per fish. So we know that we are going to spend $12 or less, right? Because we only have $12. We don't have any more than 12. So our symbol is going to be less than or equal to, because we do have exactly $12. But our problem is going to end with less than or equal to $12. Now let's go back to the beginning of our problem and let's underline important information. You have $12, which you've already put into our problem, to buy 5 goldfish for your new fish tank. Write and solve an inequality that represents the price you pay per fish. So we know we're buying 5. Remember, anytime we see the word per or each, we know that that's multiplication. So I'm going to use an F since it's fish. I know I can buy 5 goldfish, but I don't know how much each goldfish is going to cost me. So 5 times F is going to be less than or equal to 12. All right, let me move this over just a little bit. But again, why is it less than or equal to? Because I know I have $12. So I can spend exactly 12 or I can spend less than 12. But I only have 12. I don't have more than that. So again, this is a simple inequality. If I want F by itself, I've got to divide both sides by 5. And so F is less than or equal to 2.4. Now, since we're talking about money, I'm going to add a 0 because I want cents, and it's $2.40. Now, the fish are going to cost me less than or equal than $2.40. So I can spend exactly $2.40 on a fish, or I need to pay less than that. But I cannot go over $2.40 per fish. So here's you a real life example of when you would use an inequality. Here's what I want you to do. We're at the end of our lesson, and so I want you to go back to example number 1, letter C, and beside it, I want you to tell me what holiday we are celebrating on Monday when we are out of school. So go back to example 1, next to letter C, I want you to write down the holiday that we are celebrating when we're out of school on Monday. That's the end of lesson 2.2 and 2.3. I'll see you guys tomorrow.